Okay, our next problem on the menu is how do we find um, the area or the volume of a triangular pyramid? So let's draw a triangular pyramid, or I guess we should specify a triangular based pyramid, because all pyramids have triangles, but if they specify a triangular, that means they have a base. That's also a triangle. So if I were to try to draw one, it would maybe look a little something like this. Maybe it'd be better if I draw this as like a dotted line to show that this is like behind the current plane. And an unfolded look at a triangular pyramid would look a little something like this. Kind of reminds me of Zelda. But yeah, you could see like if you fold up all of those, like it's kind of like a flower with its petals spread out, and you see like if all the petals folded in, it would make a nice pyramid shape with a triangular base. Okay, so to find the volume of a pyramid, it's really just simple. We find the area of base times the height divide that all by 3, and that is volume of pyramid. Really is that simple. We can run through an example. I'll draw out all the dimensions on an unfolded view, so we can all be clear on what it all means. Kind of see how that could fold up into a pyramid. It's going to take some geometric thinking to see how that works out, but I promise it does. This will make a pyramid when you fold it up properly, I think. Yeah. Okay, so let's call this our base. All these triangles are the same. So let's say we have, they're all equilateral triangles. Yeah, this definitely works. And let's say they have, the equilateral triangle has a side length of 3 centimeters. So find volume. Volume of pyramid once folded 3D. Okay, so if that's 3 centimeters, we know that's 1.5 centimeters. And an equilateral triangle is really just 2 twin 90-degree triangles. We know that that's 1.5 centimeters. We know that that's 3 centimeters. We need to find this, our horizontal side, our vertical side, rather. So we know that this, with Pythagoras' theorem, this is going to be the square root of 3 squared minus 1.5 squared. And that's with Pythagoras' theorem. So we know that that is going to have a height of So square root of 3 squared minus 1.5 squared. So that is equal to 2.5981. Just about centimeters. Okay, so let's say that we have a we want to have, let's calculate our base area. Our base area is really just like this half triangle multiplied by 2. So it's just going to be 2 times 1.5 centimeters multiplied by its height, which is, I'll write the full version, 3 squared centimeters minus 1.5 squared centimeters. So that multiplied by 2 times 1.5. That's going to give us the area of the base, which is equal to 7.79423 centimeters squared. Okay, so that's the base. Now we got to find the height. Now, since we know that all of these equilateral triangles are the same, we can pretty much conclude that our side profile of the pyramid is going to look like this too. Meaning that its height is going to be 2.5981. Since they're all equilateral triangles, like all of those triangles are going to make a 60-degree angle with like the ground, and the top is also going to be a 60-degree angle if we look at the pyramid from the side. So we know that the height has to be the same. So we know that the final volume is going to be the base area multiply that by the height, divide that all by 3, and this is what we'll get. So let's write in our full equation for the base area. It's actually just oops. Select that. Guess we'll have to rewrite it because technology is hard. 2 times 1.5 centimeters. The units are important because let's say we give it in centimeters and later on we forget and we write like kilograms. That's going to be an issue. 3 centimeters squared minus 1.5 centimeters squared. Like the whole thing squared, not just the centimeters. Multiplied by the height. And this is the height, so we can really just square this. Divide by 3. So let's calculate that. Volume is equal to calculating this real quick times 6.75 centimeter cubed. That would be how we calculate the volume of a pyramid. You got to find the area of the base and you got to find the height. Once you got to multiply those two together, divide by 3, and that's the volume of the pyramid. Sounds good? I think so. Okay, so the solution here is really just saying like okay, yeah, it's just square units. I thought we were talking about square square base pyramids, but the equation is the same for a square base pyramid. It's also going to be area of base times the height divided by 3. But a square base is going to be a little bit easier to find the base because you don't need to chop it down into like right angle triangles. Okay, cool. So let's verify the solution. The above solution is correct.